Presenting Lingo for Life, here to revolutionize language learning.
To introduce yourselves, my name is Anam.
Hi, my name is Nipun.
I'm Karan.
I'm Eric.
My name is Noah.
My name is Hamza.
I'm Ziad, and we're a team of third-year CS specialists at the University of Toronto, Mississauga.
All right, so to get started, I'm going to discuss the process we use to build our app from the ground up. So to begin, let's take a look at our project backlog. So for our project backlog, we decided to use GitHub projects because it seamlessly integrates with our GitHub and allows us to link our issues, our branches, and so on to these user stories. So as you can see, each of these user stories has a ticket number. So for example, if I take a look at this user story, it has ticket number 35, and the branch that this would be associated to would have 35 inside of the branch, as well as inside of each of our commits, we would ensure to have 35 so that we know precisely what issue this commit and this branch refers to. Furthermore, each of these issues has a priority, so the point estimate, as well as the work, as well as the number of hours it took. So the estimate, which in this case is 3. Some techniques and standards we use were that for our priority, we ensured that the priority was always in powers of 2. So as you can see, we have 8 here, we have 16, we have 4, we have 32. And this is so that we can clearly differentiate which user story is more important, which is less important, and so on. So now let's take a look at the issues. So here, these issues link to our user stories. So each of these in our backlogs, each of these would link to some issues. So right now this issue is closed. And for example, let's take a look at this issue. So this is issue number 52. So if I take a look at this issue, this is linked to this branch, dev 3.52. So notice 3 means sprint 3 and 52 is the issue number. And this is a technique we use to ensure that everything is correctly being tracked and everything can be referred back to a user story. So if I take a look at this pull request, as we can see, each of these pull request has commits in this format. So this is a standard we adopted where we started with dev, followed by the sprint number, followed by the issue number. So in this case, 3.52. And we can also click this to refer back to the issue that this branch refers to. And we also ensured that each of these were reviewed by a team member before merging. So we ensured that we had things like branch protections on to ensure that we couldn't just merge it directly. Someone had to review it. So in this case, I reviewed it. I reviewed Eric's branch, and this enabled us to effectively coordinate our project tracking. Furthermore, we can also take a look at the communication. So the communication aspect, we used Discord to communicate between each other. This year we talked about the sprints, as well as things we should be doing, reminders to make sure everyone reviews their branches, everyone creates their issues, and so on. And throughout, we use this as we also did our stand-ups on Discord. And so this was our primary mode of communication. And the reason for this was one, because everyone was just more comfortable using Discord as opposed to something like Microsoft Teams. And it was just easier for all of us because we all just had Discord installed on our computers. So now let's go back to the presentation here. Now let's talk a bit more about our project itself. So our project is called Lingo for Life. And what this does is it allows you to practice learning a new language. So what we have is a chatbot, which you can converse in with multiple languages and have real-time conversations. And as well as we have a handwriting assistant in which you can draw out characters. So let's say I want to practice my Chinese handwriting. I can draw out Chinese characters, and then it will tell me how accurate and how close I am to the Chinese characters listed. And this not only allows you to get better at speaking the language, but also writing the language. And then to kind of tie this all together, we have some score progression and daily login points to really increase user engagement and make it as interactive as we can.
Now let's talk about the market fit and context. First, we have the total addressable market, TAM. This is literally anybody who is trying to learn a new language. And according to a recent study, we found this number to be 1.5 billion people. The frictions in the market that exist that prevent us to achieve this TAM include a language dependency UI. So our UI is completely written in English. So people who don't speak English at the minimum level cannot use our application. The next one is that the users need to have a steady internet supply. So people who don't have an internet connection cannot use our application. And the third one is the trust and acceptance of AI models. The people who don't trust AI for teaching them a language wouldn't want to use our application. So if we narrow down the TAM by removing those three frictions, we get to the serviceable addressable market, which is the SAM. So our application is designed for English-speaking audiences. So this means that we have an overlap with Duolingo's current market, which is about 400 million users, plus the 350 million users that they're trying to acquire. This includes kindergarten, um, kindergarten students, or maybe their parents, or other students who are trying to learn a new language. Also, the people who are retired and just looking for a new hobby. Additionally, they're also having some struggles in the South Asian and East Asian market because their pricing is not competitive in those regions. And this claim of 750 million users is actually supported by another study that found out about 60% of the internet users are English speakers. This is from 2021, so in 2024 we should expect this number to go down to about 50%. So if we halve the 1.5 billion users, we get to 750 million users. So that's our SAM. Next is the serviceable obtainable market. So this is the market size that we think we can realistically achieve, and the time frame that we gave us is until the end of summer. So our strategies of growing to 50,000 users globally is it's more, for the most part pretty organic. We want the word of mouth initiatives, especially in Ontario schools. So just telling students to use our applications for learning French for French class or another language. Another strategy is social media outreach and leveraging our existing followership. So amongst the team, we have about 2.5 thousand followers. We can reach those followers to see if anybody wants to learn a new language, and we can go from there. The third one is content streaming platforms like Twitch and YouTube. So we would target small Twitch and YouTube streamers and encourage them to use our application on their stream. So if somebody is trying to learn a new language, they could see the product being used in action, and they might get convinced to use it. Our main competitors in this market are Duolingo, Google Translate, and handwriting multi-language. So I will give you a quick rundown of all three of those. So first, let's look at Google Translate. So Google Translate is more of a tool to translate your language from language A to language B. So if you're trying to make a quick transaction with somebody, you would use Google Translate. You would not sit down and learn the entire language. So Google Translate has a much wider audience. Pretty much literally everybody who uses the internet would use the Google Translate. However, we are targeting a subset of that audience, which are the people who are trying to take the initiative to learn that language for immersive gamified experience. So the handwriting multi-language is, let me quickly look it up. So the handwriting multi-language is an application on the App Store that we discovered. So it's a computer vision based application that has a similar functionality to our handwriting exercises feature. If you want to see if your writing in another language is legible, you would use this application and it would recognize whatever you write. And if it recognizes your thoughts as you intended, you could be confident in your language skills. We have a similar sort of feature in our application, but we do offer a more gamified experience by giving you a score for each sentence that you write, and we have preset levels. Uh, so you so that you progress from writing simpler sentences to writing harder sentences, and you gain points accordingly. And the last one is our main and biggest competitor, which is Duolingo. Biggest as in like direct conflict. So Duolingo offers a more gamified, immersive language learning experience that we aim to offer. But the key difference between us and Duolingo is that we aim to teach you a language through conversation, whereas Duolingo aims to teach you a language through quizzes and exercises. This means two things. One, that the Duolingo has a reliance on AI made content, and our approach of Duolingo has a reliance on human made content, whereas we have mostly, pretty much all of it being AI generated large language model content. And the second difference is that our philosophy in language learning is very different. So we think that having learning a language through conversation is the best way, whereas Duolingo thinks giving you exercises and quizzes is better. So this way we are catering two different schools of learning a language. So people who would want to learn a language through conversations would use our application, whereas people who want to learn a language through a gamified experience of doing like quizzes would use Duolingo.
Now we will take a look at the software architecture. We made use of microservices by having services for the chatbot, handwriting, and daily exercises models. This allows us to have fault tolerance since services are independent of each other and can be replicated separately. Furthermore, from the diagram, it can be seen that we use an MVC model. We use React as the view, Django as the controller, and the three services as models that are operated by the controller. Next, we made use of CRC cards to clearly outline responsibilities within the application. For instance, we have a sample of the three classes we used in the chatbot. From the diagram we see, there are three main components, and each of these components have dependencies within them. For example, it can be seen that the detect grammar class has a dependency of LSTM grammar model class. This gives us a good understanding of what components are connected to other classes and a sense of the development roadmap that we should follow.
Next up, we're going to demonstrate three features of Lingo for Life. So to begin, I'm going to go ahead and click on the landing page here. And notice I'm logged in as a default user AA. And you can, again, you would log in with your user ID and so on. And so we can go ahead and go into the chat feature. So in our chat feature, we're going to sort of demonstrate two types of ways you can communicate with the chatbot. So one is through the text. And when you communicate through text, you get some feedback for what you spoke. And this is using our RNN model as well as OpenAI. And then I'm also going to demonstrate through voice. So through voice, we use the Whisper model as well as Hugging Face. So these are sort of two features that we're going to demonstrate in this chat page. So first, I'm going to go ahead and type something here. So I'm going to say, how is you? And notice this is a grammatically incorrect way of saying how are you. So the feedback should tell us how are you? And then it would just respond to it. It will still respond to it correctly. And so for the next time, you can say something like, how are you? And the feedback now will say that you are correct. And again, the chatbot will respond to you as it would have if you spoke in the correct way. Furthermore, we can also integrate multiple languages into this seamlessly. We don't have to just stick to speaking English. We can type something in French, let's say. So let's say I don't know, type in something like this. So this is just the name of a song. And I'm just going to, instead of writing la, I'm going to write la, maybe and so this would be picked up by our grammar detection and depending on the context as well. So in this case, like it doesn't really make sense to say this phrase. It just means spinning in the void. The feedback might also suggest some other things that are better to say in this context. So for example, if I hit enter, it corrected, first of all, it corrected the law into law, which is exactly what we wanted. And if I send this over, again, this it's just totally confusing. The chatbot doesn't really know what you're trying to say here. But when I send this over, then the feedback might tell you, okay, this is maybe something that you're trying to say. Maybe this is better in the context in which you are speaking. So this is sort of, we're trying to fine tune this feedback to ensure that it creates gives the user the most language learning, pretty much allowing the user to learn the language as best as possible. So this is our text-based chatbot. Next up, we can go into the voice-based chatbot. So this would be feature number 2. So for feature number 2, I can start recording something and the chatbot will respond to me in that language. So first, let me go ahead and speak in English. So I can say, how are you? So right here is my recording. How are you? And now the chatbot will respond to this in English, and it would give us back an audio response. So in a couple of seconds, the audio will generate. And
I'm doing well. Thank you for asking. How about you?
And so we get a response back from the chatbot. Similarly, I can also do this in another language. So let's say in Urdu, I ask it, how are you? So, kya hal hai? Kya hal hai? And this would ask the chatbot, how are you in Urdu? And now it will respond with the same language in a couple of seconds. So let's see here.
मैं बिल्कुल ठीक हूँ, शुक्रिया। आप कैसे हैं?
And so this is precisely the response we were expecting. We were expecting it to say, this just said, I am good, thank you, how are you? And so this is how our voice-based chatbot works. And if you made some like mistake while talking, it would still try to, patch what you said. So something like, can you tell me if I'm saying this correctly? How is you? And so here I'm just asking it, okay, did I say the following correctly? Can you tell me if I'm saying this correctly? How is you? And now the chatbot will respond in audio with the appropriate response. So again, this is sort of like learning with an instructor, right? You can ask it questions and it'll respond.
It looks like you might be trying to ask, how are you? Instead of, how is you? But that's just based on the correction of the grammar. Could you clarify what you meant to say?
Yeah, so in this case, we did in fact need to say, how are you? And so this again would help us learn the language and pick up these nuances in the new language we are trying to learn. So this is feature number 2. And for feature number 3, we have the handwriting assistant. So oftentimes, like we might go to another country, you might need to write something down. And the focus of this is to practice legibility. We want to make sure that our handwriting is as legible as possible. So let me go ahead and try to write this target word as legibly as I can with my mouse. So hello. And when I hit recognize, it tells me, okay, my accuracy is 100. My score, I get a score based on this. And it also tells us that we have written the correct word. So yeah, we're good to go here. Let's say that I don't know, my E's tend to look like O's, for example, or maybe even A's. I don't know, my E might look something like this. And in this case, an English, somebody who speaks English, you can read English, might read this as hello and might think, okay, I don't know, maybe they can piece together the context, but as you can see, it isn't as legible as it needs to be. And so then it will tell you, okay, your accuracy is about 80% here, and it generates a new score. And we also have this with other languages. So for example, Hindi, I can try and write this out. So based on this, go ahead and type this or write this as best as I can. And then it would generate a score for me and tell me how legible this was here. All right. Now we recognize, and yeah, it was able to recognize this perfectly. And again, if we had like some slight words that were not written as legibly or maybe could be interpreted as other words, it would tell us which spot that was in and would tell us, okay, this is not as legible, and we would get the appropriate score. So this sort of concludes feature number 3. And so these are the 3 features that we wanted to demonstrate for Lingo for Life.
Now we will discuss the technologies used and their justifications. We used React for the front end and Django for the back end. React was used due to its component-based architecture, which promotes modular development, code reuse, and maintainability. Furthermore, we used Django for the back end due to its robust security features and SQLite 3 for the database. This is because Django provides built-in support for SQLite 3 and allows us to write queries without having to worry about SQL injection, and also automatically hashes passwords in the database.
Additionally, we used 3 types of AI for the chatbot and handwriting recognition. We mainly relied on the OpenAI and Hugging Face libraries, and we also coded up our own RNN model to improve some of the previous results. The RNN model was coded using PyTorch, and we used Google Colab GPUs to train it. Whisper was used to handle all of the sound processing and detection. Lastly, the handwriting was done mainly using the Google API, providing us with computer vision capabilities when parsing handwritten input. These APIs were used since they were easy to integrate into our code base. Additionally, a couple of group members had credits for some of these APIs, so no additional costs were needed.
Now that we have an overview of the technologies, we have the following diagram, which showcases how our technologies come together and create our chatbot. So as per the diagram, the first step in the chatbot is analyzing the user speech. We use the front end to take the user speech and transcribe it into text using Whisper. And then we take that transcribed text and we pass it over to our grammar detection and language detection. The grammar detection is powered by OpenAI and our RNN model, and the language detection is powered by Whisper. And once those processes are done, we then use OpenAI and Hugging Face to generate a response and return to the front end using a RESTful API.
All right, now let's take a deeper dive into technologies that went into the handwriting assistant. So from this diagram, you can see the steps that need to happen after the user submits their handwritten input. So first, we need to parse the drawing. And this is done using the Python imaging library, and then classified using Google Vision APIs. And then once all of this is done, the score is computed using a sigmoid function. Now, the design choice was made since the sigmoid function allows us to reward users more if they improve from a very low accuracy and less if there is improvement from an already high accuracy. Lastly, using a RESTful API, the computed accuracy and score are sent to the front end.
Moving on to the technical challenges that we faced. I'll be starting us off with the technical challenge that I faced while developing my part. First challenge we faced were grammatical inconsistencies. Originally, we were using the Spacey library for grammatical errors. However, it lacked in detecting a variety of issues and the accuracy was rather low. So to overcome this challenge, we implemented an RNN model which tackled a wider scope of issues and resulted in a higher accuracy. If we go here and we type in a sentence like this, the error is this all, it does not fit well in the sentence. So when we submit this, we get back, we cleaned the entire kitchen while our parents were out for dinner, which is the correct response. With Spacey, it would not recognize this error since it isn't a spelling error specifically. And to just quickly show the code for the RNN model, it's over here. It's a Google Colab file because we use the Google Colab GPUs to test the model and train the model as well. So yeah.
So for this challenge, one of the main issues that we faced was OCR selection. Now, initially we selected Tesseract, and Tesseract is a widely used OCR. One of the main issues with this, however, is that it doesn't really work well with handwritten usages and activities. So we had to look elsewhere, and we found the Google Cloud Vision OCR. And this one works very well. And one of the main benefits is that it provides language biases. So it works for all these supported languages as well. Now, just to provide a small test here, we have image.png, which legibly says hello. Now, if I run this with the Google API, and if I also run this with the Tesseract, you'll see that the Google API is going to print out hello, which is as needed. Now, the main issue with the Tesseract is that it'll say cannot recognize essentially.
Another issue that we had when creating the handwriting AI or fine-tuning our API was that there were certain limitations when the user uploaded an image of their handwriting. So an example of this is right here. So in this example, we can see what the sentence is saying. Here is a bad example. However, the AI had problems processing this image. Here is an example of another text that we're going to be using to compare to. And this is an example of a good text. So using Postman, I will just show a quick demo. So first is with the good sentence, and you can see that it processes it properly and has no trouble. And then with the bad sentence, you can see here that it does struggle. The way that we overcame this problem was fine-tuning our parameters and setting up a boundary for the user. We just tell the user to use a clear white background and write on ruled line if possible to get the maximum result. So comparing these two, we can see that clearly the background does not contrast with the writing, and the writing here is on an angle. So just by outlining clear guidelines when uploading a picture, we were able to
Another
overcome
challenge we faced
this
when writing
issue.
the front end was that because we wrote a lot of the front end prior to implementing the back end features, we had to write the front end with extensibility in mind. We used a lot of TypeScript in order to do this, and an example of where TypeScript helped was our fetch calls. So we create this custom fetch method, which allowed us to do something like this. So this code was written before the backend for the login was implemented, but this is the front end handler. You can see that we hard-coded the credentials, but we also documented how we expect to make API calls to the backend. So if I uncomment this, you can see that calling this custom method that I showed before gives us another method that we can use to call the backend. And because we provided input types, the login values, and the login response for the output, and as well as the method that we expect to use whenever we call this method. So if I uncomment this, we can see that if we provide the wrong types of inputs, so password is a number, or if there wasn't a password at all, then we would get an error. This way, when we go implement the backend and integrate it with the front end, we know exactly what we expect from the backend whenever we implement it. And because we also have the output types defined here, we can expect the data output to also have that shape.
Moving on to the technical challenge that I faced. So I was in charge of integrating the audio aspect into the chatbot itself. And here I was unable to do this at first. So when I was trying to integrate the chatbot, the audio was unplayable. And this is because I was passing this directly into the chat itself. So notice right here, I have this user audio element. And when you're passing this in directly, React tends to serialize these. So by the time you get to the return right here, so here, this is where you're actually returning the HTML. It'll try to render the message, but it actually won't be able to because it gets serialized. And so the fix here was to first pass in just the URL and then parse the URL in the return. So this is what we ended up doing. So the fix here was to just check if the message we receive is a blob URL. And if it is a URL, then construct the audio within the return. So earlier we were constructing this part up here. We were constructing it here, but we actually wanted to construct it down there. And so that helped me solve my technical challenge. And so as you can see, this is how it looked before. We had to pass in links, which you'd had to place separately, but now we were able to
So
successfully
the
integrate
chatbot
this
and
into
the
our
voice
chatbot.
response functionality, the multilingual chatbot that you saw in the demo, was my portion for this project. So the biggest technical challenge that I faced was that Google text to speech requires you to put the language code alongside with the text that you wanted to convert to an audio file. For example, over here we have some Urdu text, and we're using the UR code to tell Google that the text we're giving it is Urdu. So for that, we realized this pretty late that we needed like another AI model to detect the language of the ChatGPT output, so that Google text to speech works. So for that, we found through our research, we found this language detect language classifier, which gives the language of the text pretty accurately. From our testing, we conclude the accuracy to be around 95 or 97 percent. So that's how we solve this issue.
To finish off, one final challenge we faced was working with asynchronous operations to integrate the backend database to the front-end React for managing user login and registration. This was a new technology we had not been exposed to at the time while working on React and was initially difficult to grasp. We faced trouble with working with the structure of promises and loading user data, such as the username, to be displayed on the site after the user's data had been successfully retrieved. Working with these asynchronous operations proved to be convenient, but ultimately led to other complexities such as error handling, race conditions, and difficulties in debugging and managing dependencies. Nonetheless, we had overcome these challenges and continued progressing our skill regarding this topic. This concludes our session with Lingo for Life. We appreciate your patience and the time you spent with us.